This is the final review, second part. Your review problem number 35. We want to determine the graph whether the function f possesses the extrema on the interval ab. Okay, so let's say this is a, this is b. Okay, highest point is maximum, lowest point is minimum. But it looks as highest point is this, but this is open point. So this is meaning is no absolute maximum. And this is the lowest point, which is meaning is minimum. It is closable, so it exists, right? So we can say there is no maximum, but there's a minimum at x equal to b. We want to find indefinite integral. So we have to first, inside function entire derivative. 4 over x to the cube is 4 over x to the negative 3. Entire derivative is power is 1 up, so negative 3 plus 1, negative 2. So we can write it as 4 over negative 2, x to the negative 2. So this is going to be negative 2. And I'm going to put in it, this is a denominator, so negative 2 over x squared. So it becomes this indefinite integral is negative 2 over x squared plus c. Do not forget, in indefinite case, you have to be put in plus c, arbitrary, right? Practice problem 37, same thing. We want to find integral for secant tangent dx. First, we have to find entire derivative of 4 secant x tangent x. 4 is a constant, but secant x tangent x entire derivative is just the secant x, so 4 secant x. So indefinite integral is 4 secant x plus c. Practice 38, find the indefinite integral. First, you have to do inside the function entire derivative. Before that, I'm going to first simplify that. So we split two fraction and reduce x to the cube plus 2x. Entire derivative power is 1 up. It becomes 1 over 4 x to the 4 plus 2 multiple 1 over 2 x squared. 2 cancel out. It becomes 1 over 4 x to the 4 plus x squared. So this integral is this entire derivative plus c. So this is going to be our answer. Number 39, find indefinite integral. Okay, so look at this. This is not basic form and something to the power form. So we have to use substitution. So u is x cubed plus 3. So we have to be find differential. So this part is, I can changing is u to the 7. So leftover term, x squared dx, we have to be changing u term. Du over dx is x cubed plus 3 differentiation 2x squared. We multiply both sides dx. So du equal 2x squared dx. We need x squared dx. So I'm going to divide both sides 1/2 du equal to x squared dx. So original this equation, I just swapped the order. So this is u to the 7 and this is 1/2 du. I changing x term to u term. So 1/2 is a constant, we can take out. And u to the 7 going up power, so a, so 1/2, 1 over 8, u to the 8 plus c. And we have to going back to x term. You plug in x cubed plus 3, so 1 over 16, x to the cube plus 3 to the 8 power plus c. This is our indefinite integral. Practice problem number 41. We want to find indefinite integral. Okay, so inside the function, this is not basic form, so we have to using substitution. Usually square root case, inside has to be u, so u is 2x minus 1. Okay, I'm going to differentiation to changing is dx. Du over dx is 2. We multiply both sides dx, so du equal to 2 dx. I'm going to divide both sides 2, so 1/2 du equal to dx. So this equation, square root is 2x minus 1 to the 1/2 power, but this is denominator, put in its numerator, become square root 2x minus 1 to the negative 1 over 2. So this is become u to the negative 1/2. This one is 1/2 du. I change x term to u term. So it looks like this. 1/2 is a constant, so we can take out. And power is 1 up. Negative 1 over 2 plus 1 is 1 over 2. So reciprocal 2 over 1 u to the 1/2 plus c. This is cancelled out. So u, so 2x minus 1 to the 1/2 plus c. But 1/2 is meaning is square root. So we can rewrite square root 2x minus 1 plus c. This one is our indefinite integral. Practice problem number 43. We want to find definite integral. So first you have to do find entire derivative sine x. So negative cosine x, right? So definite case, top, this one is placed, you plug in x, so cosine 5 pi over 4 minus, and bottom cosine pi over 2. Cosine 5 pi over 4, using unit circle, we know negative square root 2 over 2 minus cosine this value using unit circle, it is 0. So this is 0, so it becomes negative square root 2 over 2. Practice number 44. We want to find definite integral from 4 to 9 square root x dx. First, we have to find inside the entire derivative. Square root x is x to the 1 over 2. Power is 1 up, is mean power is 3 over 2. So first, reciprocal 2 over 3, x to the 3 over 2. This is 1 over our entire derivative. Indefinite case, from here, we plug in top value 9 minus and plug in 4. Okay, so first one is 18 minus, second value is 16 over 3, put together 38 over 3. So this is our definite integral. Okay, practice 45. We want to write this area using integral. Okay, so usually integral is based on is x, right? So it looks is from 0 and 2. Graph is above, so integral value is the same thing is the area. So from x value is 0 and 2, 0 and 2, the inside function x squared plus 1 dx. Integral case, this s interval and dx is pair, do not forget. Practice 47. Find y equal to f of x. If f double prime equal to x squared, f prime 0 equal to 6, f 0 is negative 2. First, we have to find f prime, right? F prime is integral x squared dx. So this entire derivative 1/3 x cubed plus c. But here is the condition, f prime 0 equal to 6. When is x value 0? F prime value is 6. So this place you plug in 0 and 6, and this place you plug in 0, you can find its c value. So c is 6. So f prime is 1 over 3 x cubed plus 6. And after that, we have to find f. F is f prime integral, right? So f of x is integral 1/3 x cubed plus 6 dx. Power is 1 up. So 1/3 multiple 1 over 4 x to the 4, 6 case, entire derivative 6x and plus c. But we know f0 is negative 2. To find c, we have to plug in that. Okay, f of x value is negative 2 when x value is 0. So I plug in here negative 2 and plug in here x place is 0. Okay, so this is going to be 0. So c is negative 2. So f of x is this multiplication 1 over 12 x to the 4 plus 6x minus 2. This is our f of x. Number 48. Find average value of f of x on interval 0, 2. So first you have to do find entire derivative f of x. So this is what? 4 over 3 x to the cube plus 3x. After that, we have find the definite integral from 0 and 2. So in here, entire derivative, we plug in 2 and we plug in 0. So 0 case, this is 0, right? So it becomes 50 over 3. average of value is what? The formula is 1 over b minus a. So 2 minus 0 and definite integral. So 1/2 multiple 50 over 3. So 25 over 3 gonna be our average value of f on the interval 0, 2. Practice number 49. A spherical air balloon is inflated at the rate of 6 cubic centimeters per minute. At what rate is the radius of air balloon increasing when its radius is 10 centimeters? So this is what? The spherical balloon. So the volume formula is 4 pi over 3 r to the cube. Okay, this is rate, so we're going to be differentiation with respect time. So left side, dv over dt, and here the constant 4 pi over 3 multiple r to the cube is what? 3r to the square, but r is a function of t, so you have to multiple dr over dt. So the condition is they said the rate of change volume is 6 cubic centimeters per minute, so we know it's this value. When radius is 10 centimeters, so we know it's this. So we have to find the changing of rate of radius. So 3, 3 cancel out like this. So I'm going to use what? Plug in this value. So 6 equals 4 pi multiple 10 to the square dr over dt. So this is going to be 400 pi. So we're going to divide both sides, 400 pi. 6 over 400 pi equal dr over dt. So reduce, so 3, 200. So dr over dt is 3 over 200 pi. This is rate of change, centimeter per minute. So this is the rate of radius. Practice problem 50. The management of a large department store wished to add a fencing in rectangular storage yard of 80,000 square feet using the building as one side of yard. Okay, so situation is what? This is a building. We want to make it is what? Like this, right? Fence. So we need is 3-side fence. So let's say this W, W, and L. And they said is this area has to be 80,000. Okay. So we know is 1. Fencing area is length time width. So area is 80,000 length time width. We can make it is what? W is 80,000 over L. Okay. Find the minimum amount of fence. So we want to find fencing amount. Okay. So in other words, fencing amount is F is L, 1L, and 2W. I can make it one variable, W place, I plug in 80,000 over L. 2 multiple 80,000, 160,000 over L. So this one is put in its numerator, it becomes L plus 160,000 L to the negative 1. Minimum maximum case, it happened critical point. So we have to find prime with respect L. So f prime is L is 1. Okay, negative 1, bring it down. So negative 160,000, power is 1 less, negative 2 power. It becomes 1 minus 160,000 over L squared. Critical point is this value equal to 0 value. So we have to find equal to 0 value. In other words, 1 equal 160,000 over L squared. We multiply L squared both sides, then L squared is 160,000. What this is meaning is we taking is both sides square root. L is what? 400. Okay, so L is 400. We can plug in here. So W is what? 80,000 over 400. So it is 200. But we want to find the minimum amount of the fencing material. So F, right? F is L plus 2W. So 400 plus 2 multiple 200. So it is what? 800 feet. So this is our answer. Practice number 51. An open box is made from 6 foot by 8 foot rectangular piece of material. By cutting equal square from each corner and turn up the side. Find the volume of a large box. Okay, here we go. So this is what 6 and 8. We cut it is what both is a square. So we're gonna be cut it is this. Ooh. So it looks like this, and turn up in here. Okay, so this is going to be my height, right? That is x. Okay, and this is my width. So 6x minus x, so 6 minus 2x. And this is my length, so 8 minus 2x. Okay, so height is x, length is 6 minus 2x, width is 8 minus 2x. But this has to be linked, so x has to be positive, but it cannot be bigger than 3. Bigger than 3 case, this is going to be negative. Okay, so we know it's that much. Volume is what? Length time width time height. So this one. We expand it, then it's 4x to the cube minus 28x squared plus 48x. So common factor is, number is 4, so I take out is 4, x to the cube minus 7x squared plus 12x. I want to find is maximum volume, large the box, which is meaning is we have to find critical point. So volume differentiation is 4, okay, x to the cube differentiate 3x squared, negative 7x squared is negative 14x, and 12x is 12. Okay, so critical point is what equal to 0 value, right? So we divide it is 4, so we have to find is this equal to 0. So quadratic formula. So I have to be plugging quadratic formula. Then 14 plus minus equal to 52 over 6. So there's a two value, 14 plus 52 over 6, or 14 minus 52 over 6. If you plug in your calculator, this is what 3.5. This one is 1.31. But x is what cannot be bigger than 3. So first is not. So x value is 14 minus square root of 52 over 6. And this value you plug in volume formula in here. Then you got 24.26. So practice problem 52. Using trapezoid rule with n is 4 to approximate integral from 0 to n1 1 over x minus 2 to the square dx. You're supposed to be not plug in your calculator to find this value, okay? So from 0 and 1, we divide 4 p's. So this is 0.5, this is 0.25, this is 0.75, right? First you have to do is, let is f of x is 1 over x minus 2 square. You have to find each one corresponding y value. F of 0 is 1 over 4. And you plug in f of 1 over 4 because 0.25 is 1 over 4. Then it's 16 over 49. F of 1 half, 0.5 is 4 over 9. And f of 3 over 4, 0.75 is 3 over 4. So 16 over 25. F of 1 is 1. Trapezoid is the approximate this is what? The each interval, this delta x, 0.25, right? 0.25 divided 2, parentheses, what? First this one, 1 over 4 plus 2 times, between that is twice. 2 times 16 over 49 plus 2 times 4 multiple 9 plus 2 times 16 over 25. But last one is you not multiple 2. So first the last one is only 1. Okay, if you calculate this, you got 0.5090. This is our approximation value.